Hi, my name is Elsie Dumashi, and today I'm going to talk about my bdat 1002 final project on weather data analysis. Um, the project aims to dive deep into the nuances of weather data with potential understanding of how this affects our climate dynamics and ways of improving accuracy of predictions. For this particular project, I'm going to focus on using both Hive and Spark to help with my analysis. I'll go on with a quick overview. For the project, I'm going to do a quick introduction. Then I'll talk about the data acquisition process, the data cleaning process, how I was able to visualize my data, and include a quick conclusion to explain how everything came together. So for the quick introduction here, it's a southeast data set. So it's the southeast of Brazil, and it's a comprehensive collection of different observations, and it captures a diverse range of climatic factors. So examples are of the parameters are precipitation, atmospheric pressure, temperature, humidity, and wind. It also includes different geographical information such as the latitude and longitude and height of the particular locations. The data set was divided into regions and stations, and it includes the date and times which these informations were collected. For the particular data set that I was able to choose, I got it from Kaggle, and it was 2.3 gigabytes. It had 28 columns, and basically the main focus of my analysis was to be able to use Hive and Spark to be able to do advanced data processing and analysis, and to be able to identify intricate patterns and trends within this data set that I was able to find. Now, with my project timeline, I'm going to explain the steps that I took in regards to my data analysis. I began with acquiring the data, so the data acquisition process, which I got through Kaggle, and I downloaded it onto my device. It was a longer process than I expected because of the size of the data. As I mentioned, it was 2.3 gigabytes, so it's a very large data set. Then I was able to go through the process of handling and uploading of the data, which we did using the Google console. I was able to upload that data, and then I used the data cleaning process on Hive, data analysis using Spark, and I also created my final report where I bring everything together in regards to my analysis. Now, the next thing I'm going to talk about is how my data acquisition process, and I'll walk you through the steps which I took. First off was the data upload. The data was found on Kaggle and uploaded to the Google console. I created a bucket and I named the bucket bdat1002 bucket. In this bucket is where I uploaded the data set and called it southeast.csv. So I uploaded this data set onto this bucket. I also created a cluster. With a cluster, VM instance was created to be able to use Hive to help in the cleaning of the data. The cluster was called bdat1002. And this is what we used, connecting the SSH to be able to analyze the data for the cleaning. When we got into the VM instance, I created a directory called Hive data and loaded the data into it. So here you can see in this code that I was able to create the directory, the line that says mkdir Hive data. I created the directory called Hive data. I also showed how I was able to see that the directory was actually created, and then using gsutil, I used it to upload the data into the directory, and I'm able to see that yes, the 2.3 gigabytes of data was uploaded into our directory. Through the data cleaning process, I made sure that my data was actually available by viewing the first 5 rows, and then I got into the Hive where I created the database base and I called it Southeast, and then I just made sure that the database was actually created. After creating the database, I created an external table called Southeast table, using all the columns that I had for my data set. And then to confirm that this was actually created, I also did a select statement to be able to view the first 10 rows. The data cleaning process was actually pretty simple. Um, what I focused on was using queries to remove different null values, because the data sets did have quite a number of null values. I also wanted to remove any sort of unwanted characters and also any duplicates that came with the data set, as well as any negatives. So I used the query to be able to do this, and then I used the select statement here as well to be able to view whether this was done properly. And if you look at the data set, you're able to see that this is a cleaner version as compared to the previous one. After doing this, we have the clean data. So just to be able to continue using this clean data in Spark, I had to upload it to the bucket. So I used the code to create a new directory called Southeast2, where I uploaded the data sets into it. After that, I ensured that the data set was present and put into the cluster that we initially created. And then I used ls to be able to view that the data set was actually in the directory. And then I uploaded the data set using GSU2 here to move it again. Now, the next thing I'm going to talk about is the data analysis process, which I did using Spark. So using Spark, the first thing I was focused on was importing all the necessary libraries that I'd need for my process. So some of the libraries that were used were pandas and matplotlib, to be able to go through my data analysis process. I also created the schema using all the initial columns I had from my data set. So this is the schema that I created, and made sure to include all the data types there to properly get my code running. Now, the main focus here was to create different queries and to help in the data transformation. So the first one I wanted to do was to create different aggregates, which I did here. And the first aggregation was by region, by state, and by station. Our data sets does include different columns, and we have different stations and regions in our Southeast data set. So I did the aggregation to be able to do that for my first analysis. And then I'm able to see the results here. So that the code provided above helps to show the data, and that the three tables show the outputs from the code. The next thing I wanted to do was to be able to convert my data columns to a timestamp to ensure that when I go through my querying process, the system is able to understand that these are actually this is actually a date value, which is what I did for my next step. And then I also wanted to extract the year into a separate column on its own, which the code above shows how to extract the year, and the screenshot is able to show that yes, the year was successfully extracted. For my research questions, I had a few research questions that I wanted to focus on, and the first one was finding the averages of precipitation, temperature, which I did using my data set. And now with the first step, I used this calculated averages code to be able to find my average for my data set. Now, this is the visualization. When you initially look at this visualization, it does look off because it's focused more on negative values because most of the averages were on the negative end. So what I had to do was I had to do some more data cleaning because we all know that temperature cannot be negative 621. Well, not in this part of the world, not in Brazil. So I decided to go through a new data cleaning process by excluding negatives. So to only use data greater than 0. So this is the data, the code that shows how to do that. And it was focused on getting the averages again, but for the same values, average temperature, precipitation, and relative humidity, but this time excluding any negative values. And now this particular table, this particular bar chart looks so much better because it has excluded the negative value. So you can see for temperature, we have an average value of almost just around the 20s. And then the relative humidity, you can also see that, which is as expected. And precipitation was very low. That's why it looks like it's not visible, but it's because it's very, very low. The next research question that I focused on was how does the average temperature vary across different states? And I used my code to be able to get this done. And for temperature, you can see that in the states which says ES, it has the highest temperature compared to the other 3 states. Then the next question was how does the average precipitation vary across different states in the southeast region? Using my code again, I'm able to see that the the precipitation doesn't differ by so much, but you can see that there's an obvious higher state here as well. And the last one was how does average wind speed vary across different states? I also was able to use the code to be able to get that value, and you can see that the states that says ES is also on the higher end. For my last research question, it was how does the distribution of total precipitation vary among selected states in the south and southeast region, and what insights can be gained from this variation in the precipitation patterns. So here, what I did to be able to easily analyze the data was to use a pie chart. And in this pie, I did the code. Then this pie chart, you can obviously see that the region that says MG has the highest precipitation compared to the different states. I also made sure to exclude negative values because we can't have that those negative values affected the data set, and also any null values would also affect the data set. And I was able to get this distribution for the precipitation where you can see that the MG state has the highest sum, followed by the SP state, and then RJ um next, and then ES. So you're able to see the distribution clearly using a pie chart. That's why I decided to use a pie chart so that when you look at it, it's obvious which state and you're able to understand the pattern here. Now, what were my insights at the end of the day? So the first thing was that I observed that the average temperature is around 22 degrees, which indicates a moderate climate as expected. The average precipitation was relatively low at 0.15 millimeters. That's why on the graph, you're able to see that it looks like it's non-existent because it's a very small value. And this suggests the climate in the southeast region is at a drier climate. Also for our relative humidity is around 72.23%, which provides us insights into the moisture content in the air. For the second question that I asked, the analysis didn't really review a significant difference in the averages of the temperature levels and winds and precipitation. So if you recall the bar chart that I showed initially, we can see that the levels are almost the same, even though there's a slight difference between all through the four states. A possible explanation could be like there's a limited difference in there's a limited difference in the different regions in the southeast data sets because of um, geographical similarities, which is expected, especially for a country which is not as big as maybe Canada or any bigger country. The similarities between different states are very close, especially in regards to weather patterns. And the last one was after the visualization of the pie chart which I created, you can see where Minas Gerais, which is MG, which is what we refer to as MG all throughout, has the highest precipitation, and Espirito Santo, which is ES, has the lowest precipitation. So to conclude, I was able to use my data set to be able to analyze the different regions of the Southeast data set. And I was able to focus on key factors such as the temperature, precipitation, and wind speeds to be able to understand the patterns and the variations. Thank you so much for listening to my video, and do have a great day.